Bismillahirrahmanirrahim. Quote of the day. Every day brings new choices. Today, the topic of my presentation is independent sample t-test with examples, and I will be presenting it under the supervision of Professor Dr. Saira Afzal. Learning outlines. Independent sample t-test definition, its use, hypothesis, overall procedure. Formula for the t-test for testing the difference between two means of independent samples. Assumptions for the t-test for two independent means. Examples, calculating the confidence interval for the difference of two means using t-test, recent updates, and MCQs. Learning objective. At the end of the presentation, participants will be able to define the independent t-test, its use, assumptions, and how to test the difference between two means of the independent sample using this test. What is an independent sample t-test? An independent samples t-test evaluates whether two means from the two samples of the same dependent variable are significantly different from one another. Example, same dependent variable is baby birth weight, and independent variable, two groups of expectant mothers. Those who drink less than 2 bottles of water per day and more than 2 bottles of water per day. Note, anytime you run an independent samples t-test, you will have two levels of something. In this case, expectant mothers who consume less than 2 bottles, one group, and more than 2 bottles, second group of water per day. A research question will be about group differences. Who is more likely to engage in religious practices, male, female, Jews, monks, urban city dwellers, inner city residents? You run an independent sample t-test when there is only one dependent variable, like in this case, baby birth weight, which we are measuring across both the groups. It is used only with the ratio interval scale, and the data is reasonably normally distributed. An independent t-test is appropriate to run when the research question deals with the differences between the two sample means. Working with interval ratio data, the distribution is reasonably normal. There is one independent variable with two levels with the same dependent variable like baby birth weight. Independent sample t-test hypothesis. Null hypothesis. There is no significant difference between the expectant mothers who drink more than 2 water bottles per day to those who drink less than 2 water bottles per day. Two independent groups in terms of baby weight, which is the dependent variable. So null hypothesis will be equal to mu1 is equals to mu2. Alternative hypothesis. There is significant difference between the expectant mothers who drink more than 2 water bottles per day to those who drink less than 2 water bottles per day in terms of baby weight, which is mu1 is not equal to mu2. Overall procedure. So we need two t-values, the calculated t-value and critical t-values. If the calculated t-value is greater than the critical t-value, then we will reject the null hypothesis. Testing the difference between two means of independent sample using the t-test. The z-test was used to test the difference between two means when the population standard deviations were known and the variables were normally or approximately normally distributed, and when both sample sizes were greater than or equal to 30. In many situations, however, these conditions cannot be met. That is, the population standard deviations are not known. In this case, a t-test is used to test the difference between means when the two samples are independent and when the samples are taken from two normally or approximately normally distributed populations. Samples are independent samples when they are not related. Also, it will be assumed that the variances are not equal. Formula for the t-test for testing the difference between two means of independent sample. So variances are assumed to be unequal, and this is the formula where the degrees of freedom are equal to the smaller number of n1 minus 1 and n2 minus 1. The formula follows the format of test value is equal to observed value minus expected value over standard error, where x1 minus x2 is the observed difference between the sample means, where the expected value mu1 minus mu2 is equal to 0 when no differences between the population means is hypothesized. The denominator, square root of s1 over n1 plus s2 over n2, is the standard error of the difference between the two means. Since mathematical derivation of the standard error is somewhat complicated, it will be omitted here. Assumptions for the t-test for two independent means. Assumptions for the t-test for two independent means when sigma 1, sigma 1 and sigma 2 are unknown. The samples are random samples. When samples are independent of one another, the sample sizes are less than 30, the populations must be normally or approximately normally distributed. This is an example of the average size of a farm in Indiana County, Pennsylvania is 191 acres. The average size of the farm in Green Country, Pennsylvania is 199 acres. Assume that the data were obtained from two samples with standard deviations of 38 and 12 acres respectively and sample sizes of 8 and 10 respectively. Can it be concluded at alpha 0.05 that the average size of the farms in the two countries is different? Assume the populations are normally distributed. So step one will be, we will state the hypothesis and then identify the claims for the means, which is μ1 is equals to μ2, and alternative hypothesis will be μ1 is not equal to μ2. Finding the critical value, since the test is a two-tailed test and alpha is 0.05, we will, and the variances are unequal, the degrees of freedom are the smaller of n1 minus 1 and n2 minus 1. In this case, the degrees of freedom will be 8, 1 minus 1 is equal to 7. Hence, from the table F, the critical values will be plus 2.365 and minus 2.365. We will compute the test values in step 3. Since the variances are unequal, use the first formula. We will be using the previous formula for the t-test for calculating the difference between two means. Putting the values in the formula, we will get minus 0.57. Now we will make the decision. We will not reject the null hypothesis because since the minus 0.57 is less than minus 2.365, which was the critical value. Confidence intervals can also be found for the difference between two means with this formula. Variances are assumed to be unequal. The formula for the confidence interval is given, which is x1 minus x2 minus the critical values, and then the square root of s1 over n1 plus s2 over n1 less than μ1 minus μ2. And which is less than is equal to x1 minus x2 plus critical values and square root of s1 over n1 plus s2 over n2 square. And degrees of freedom will be the smaller or value of n1 minus 1 or n2 minus 1. Putting the data from the example above in the formula to calculate the confidence interval. Find a 95% confidence interval for the data in the previous example. So we will substitute the values in this formula. And by substituting the values in this formula, we will get minus 41.02 less than μ1 minus μ2 over less than 25.02. Since 0 is contained in the interval, the decision is to not reject the null hypothesis. If the variances are assumed to be equal or the pool t-test, there are actually two different options for the use of t-test. One option is used when the variances of the population are not equal, and the other option is used when the variances are equal. To determine when two sample variances are equal, the researcher can use an F-test when the variances are assumed to be equal. Following formula is used. This formula is used when the variances are assumed to be equal, and it also follows the format of test value is equal to observed value minus expected value over the standard error. For a numerator, the terms are the same as in the previously given formula. However, a note of explanation is needed for the denominator of the second test statistic. Since both populations are assumed to have the same variance, the standard error is computed with what is called a pool estimate of the variance. A pool estimate of the variance is a weighted average of the variance using two sample variances and the degrees of freedom of each variance as the weights. Which t-test to use? The following flowchart can be used to determine which t-test to use based on the characteristics of the sample sets. The key items to consider include the similarity of the sample records, the number of data records in each sample set, and the variance of each sample set. So when the two sample sets are same and related, yes, we will use the dependent dependent t-test or the pair t-test. If the two sample sets are not related, then we will use are the two sample sets of the same size, then we will use the equal variance independent test. And if the two sample sets have the same variances, then we will also use the equal variance and the unequal variance, which is the independent t-test. Example of an independent t-test from the literature. Differences between the smokers and non-smokers in the regional gray matter volume and densities. So Brody et al. In 2004 conducted a study to find the differences between the brain volumes of the smokers and non-smoker. In this study, he used the independent t-test for calculating the difference between the two brain volumes, and the results are shown, which you can see. He is used the student t-test in the results to calculate the means between the two. Recent updates: outlier removal, sum scores, and the inflation of the type 1 error rate in the independent samples t-test, the power of alternatives and recommendations. Abstract: in the psychology, outliers are often excluded before running an independent sample t-test, and data are often non-normal because of the use of sum scores based on tests and questionnaires. The article concerns the handling of outliers in the context of independent sample t-tests applied to non-normal sum scores. After reviewing common practice, we present results of simulations of artificial and actual psychological data which show that the removal of outliers based on commonly used z-values, thresholds thresholds of artificial and actual threshold severely increases the type 1 error rate. We found that type 1 error rate of above 20% after removing outliers with a threshold value of z is equal to 2. In a short and difficult test, inflations of type 1 error rates are particularly severe when researchers are given the freedom to alter the threshold values of Z after having seen the effects of thereof and outcomes. We recommend the use of non-parametric Mann-Whitney-Wilcoxon test or robust Human-Welk test when without removing the outliers. These alternatives to independent sample t-tests are found to have nominal type 1 error rates with a minimal loss of power when no outliers are present in the data, and to have nominal type 1 error rates and good power when outliers are present. MCQs. Two random samples have been selected and a two-sample t-test for the difference in a population means is conducted with a null hypothesis mu1 is equal to mu2 versus alternative hypothesis mu1 is not equal to mu2. The results are S1 2.5, X1 9.7, N1 30, S2 2.9, X2 9.1, and N2 35. The standard error of the sampling distribution is 0.408, 0.669, 0.997, 0.781, and 0.551. Okay, the answer will be B. I have shown the solution. To calculate the standard error, you will take this formula from the denominator, which is square root of S1 over N1 plus S2 over N2. And by substituting the values in this formula, you will get the standard error, which is 0.669. In case of testing the difference between means of two independent samples, the degrees of freedom are equal to A, N1 minus N2, B, N1 minus 1, C, N2 minus 1, D, smaller of N1 minus 1 or N2 minus 1, E, larger of N1 minus 1 or N2 minus 1. Anyone?
E.
No, it's a D, smaller of N1 minus 1 or N2 minus 1. Third, two random samples have been selected and two sample t-tests for the difference in the population means is conducted with null hypothesis mu1 is equal to mu2 versus alternative hypothesis mu1 is greater than mu2. The results are S1 2.5, X1 9.7, N1 30, S2 2.9, X2 9.1, and N2 35. The value of the test statistic is 0.634, B 0.543, C 1.456, D 2.457, and E 0.896. We will have to calculate the test value in this. So the answer will be E, which is shown. We will use this formula for calculating the t value, and by substituting the values in the formula, we get 0.896. So option E will be the correct answer. To test the equality of two variances, which test would you use? A chi-square, B independent t-test, C dependent t-test, D f-test, or E z-test?
B.
No, it's f-test, D.
B.
It's D f-test. Which test is used to test the difference between two sample means when the standard deviations of population are known? A z-test, B chi-square, C dependent t-test, D independent t-test, E f-test.
D.
It's A z-test. So when the population standard deviations are known, we will use a z-test. A study was done to see if there's difference between the number of sick days men take and the number of sick days women take. A random sample of 9 men found that the mean number of sick days was 5.5 and the standard deviation of the sample was 1.23. A random sample of 7 women found that the mean was 4.3 days and a standard deviation of 1.19 days. What will be the test value? A 1.972, B 2.678, C 5.678, D 4.789, and E 9.054. So again, we will have to calculate the t value, and the formula is given. Substituting the values from the above example in the formula, we get 1.972. So the correct answer will be A, 1.972. Calculate the 95% confidence interval for the data in the MCQ number 6. The critical values at alpha 0.05 are plus 2.447 and minus 2.447, and degrees of freedom is equal to 6. So you will have to use these values, and then you will have to calculate the confidence interval. Option A, minus 0.289 less than mu1 minus mu2 less than 2.689. Option B, plus 6.789 less than minus 7.89. C, 4.789 less than mu1 minus mu2 less than 6.789. D, 6.756 less than mu1 minus mu2 less than 8.9, and E 5.89 less than mu1 minus mu2 and less 7.967. So here's the solution. By substituting these values in the formula of the confidence interval, we get minus 0.289 less than mu1 minus mu2 less than 2.689. So option A will be the correct answer. A company collects data on the lengths of telephone calls made by employees in two different divisions. The mean and standard deviation for the sale division are 10.26 and 8.56 respectively. The mean and standard deviation for the shipping and receiving division are 6.93 and 4.93 respectively. The hypothesis will be tested by A, dependent t-test, B, independent t-test, C, z-test, D, chi-square test, and E, f-test. Anyone? It's a B, independent t-test. A study was done to see the differences between the salaries of men and women in the same department of the same designation. At alpha 0.05, critical values are plus 2.457 and minus 2.457. The computed t value is 1.297. Which of the following assumptions must be fulfilled for this test? A, samples should be random. B, samples should be non-random. Population standard deviations must be known. Samples should be dependent. E, sample size should be large.
A.
Yes, A is the right answers. The samples should be random. A study was done by Broody et al. 2004 to know the difference between the brain volumes of smokers and non-smoker. The null hypothesis will be rejected if computed t-value is greater than critical t-value, computed t-value is less than critical t-value, computed t-value is equal to critical t-value, and significance level should be greater than the critical value. E, there's no difference between the means.
A.
Yes, A is the right answer. Computed t-value should be greater than the critical t-value, then we will reject the null hypothesis. This is the key, and thank you.
Thank you very much. Would you please like to stop the recording so that we can discuss it?